All right. Today we are doing 1.8. Oh, dot eight. Um, this is about radicals, and it's arithmetic with radicals. So it's something I think you've seen it before, but we haven't went in depth into it. So there's some product rules or product quotient and rational rules for this. So the product rule, and this I'm going to see if I can. hmm, This is really slow. Okay. The product rule says that if you have something like square root of n of AB equal to that is equal that okay, I'm sorry, that is equal to the square root of n a times the square root of b to the n. So for example, if you had something like the cubed root of 16 x to the fourth, you could say that that is equal to, put my leaf there, 16 cubed times the 3 again. That's a 3, trust me, x to the fourth. So you can split it apart like this. And that'll be helpful when you're trying to do arithmetic with radicals. So the next rule is the quotient rule. I'm going to try to write it like this. Quotient rule. That says quotient rule, even though it don't look like it. So that says that, okay, if I have something like this with an A over B, you can set that equal to like this, A over B. So you can separate the division symbol out. So for example, if you had this guy, 3y, the square root of 3y 4x, you could make it equal 3y 4x separated like that. That's a y. Just trust me. Okay. There's also the rational exponent property. And these are in your book, but I wanted to go over them because um, these are things that you will be using throughout this chapter. So, or this section, I guess. That property says if you have a b, whatever, square root or a cube, or a b root. How about a b root? Let's make it a b root. And let's say if you have x to a here, you can rewrite this as x a over b. So this is the exponent of x. This right, the a over b is the exponent of x. So you can rewrite this to be this. That's going to be very helpful later. So, for example, I'll give you an example. If we had a 4, and this is a 5x cubed, then you could rewrite this as 5. So we're splitting it apart. Remember, this is multiplication. We can use this product rule So split these apart. And at the same time splitting apart, we can use the rational exponent rule. So 5, 1 over a quarter. Now, where did the 1 come from? The 1 was understood right here. So we took the 5's 1, wrote it on top, and we took the outer and put it on the bottom. Now the x here, you would just rewrite it times x. You don't have to put the times, you can just put the x. And then 3 over 4. The 3's from the exponent of the 3, and the 4's from the uh, fourth root exponent there. So now we will go through some examples. So the first example is addition and subtraction of radicals. And we have our product, we have our rules here that we can follow that will help us in doing this. So let me clear the screen. And now, the first example. So the first example is 2 square root of 7 minus 5 square root of 7. To solve this, we simply just do the math. So we know square root of 7, we can't really simplify, so we're just going to leave those alone. So 2 minus 5 is -3 and square root of 7. And that's your answer. So the next example, we have 15 square root of 3 plus 4 square root of 12. To solve this, we can actually break up one of these. We know the square root of 3, we can't really do anything. We can't simplify that. But the square root of 12, we can simplify that. And the way we do it is basically factoring. So the same thing you've been doing, you have a 12, and you have factors of 1 and 12, 2 and 6, 3 and 4. So what we can do is say, well, which one has a square root, a clean square root, basically. So the answer is 4. 4 has a clean square root. So let's rewrite this one as, let's do it this way. We know how to factor, that's easy. 15 square root of 3 plus 4 square root of 3 times 4. Now, we can do this because basically because of our product rule. Now, we're not pulling them both out into separate squares, but this is what you can do. So if you took the square root of 4, so what's the square root of 4? And it is 2. So you took that 2 and you multiplied it by this. What would your answer be? It would be 8. And then that gets rid of this 4, and you're 8 square root of 3. So you can rewrite this as 15 square root of 3 plus 8 square root of 3. Now this square root of 3 right here came from right here. We got rid of this, and this is what was left. So this is the final product. We still need to do the addition. So 15 plus 8 is 23, and the square root of 3. And that is the answer right there. Okay, let's do yet another example. So let's do a fun one. This ought to be fun. A cube root of 625 plus, oh, made my little wing too far. Okay. Plus 4 square root of, oh no. Cube root, oh, you know what? Oh, I'm not writing that like that because looks like horrible stuff. Okay, so now we're at cube root. 320 there. Now, how do we break this up? Well, one thing we can do is we can simplify the numbers inside by just finding the factors that work. Now, what factors are we trying to find working? That's the biggest question, right? Well, we want to find something that's cleanly rooted by this 3. So if you get your calculator and you can like 625. If we do a square root of 3 on that, actually my calculator is messed up. Huh, okay, well, I have to do it manually then. So anyway, just take my word for it. 625 does not cleanly square root of 3, and neither does 320. So let's do some simplification. So let me get rid of some of this. Let me just get rid of all of this. Now, let's say 625. What's our square? What's our factors? So 1 and 625, 2 and what? You have a calculator too, right? Do you? All right, 2 don't work. So what about ah, what about 3? Does 3 work? I don't know. Should we use our handy dandy little calculator to figure that out? I think maybe we should. 625 divided by 3. That didn't work either. So what number in the world is going to work with 625? Oh, wait, it ends in 5. Look at that. Let's put a 5 on there. Now, what does 5 give us out of 625? That is 125. I think we can stop there. Now, let's do, so we're going to use these for 625. Now, for 320, excuse me, we're going to do the same thing. So I know we can use 1 and 320, which is not going to help us at all. But 2, I mean, yeah, we could use 2. But I'm saying since this was a 5 here, let's use 5 here. Because you want to simplify to make them the same if you can. So let's do that. Let's make it 5 and 320. I mean, oh my goodness. 5 and 64. Now, it is 9 o'clock at night, so I'm having some difficulties here. All right. So let's rewrite this as the cube root of 5 times 125. plus the 4 to the cube root, or 4 times the cube root of 5 times 64. Now, this guy will come out, will cube out really well, and this guy will too. So let's do that. 125 is 5. So the cube root of 125 is 5. So what we're going to do is pull that out. I'm going to write this as 5 cube of 5 plus, now the cube root of 64, we can do this on the calculator also. On my calculator, I just push the number 64, the second key, the nth root button, and then I push the 3 for the cube root. And I push it. So this one is a 4. So we'll pull that 4 out. So this 4 goes here. So we'll just multiply them, which is 4 times 4, 16, and then we're down to same. Now we'll add. We can combine these two now because they are the same. And we'll just add them up. So 5 plus 16 is 21. And we're looking at cube root of 5. And that's the answer. All right. Let's try another example of these. This one involves powers and variables. So we have the 5th root of a to the 10th. That is a 10 root, not B12. B to the 12th, it's not B12 vitamins. Plus 5th root of 32x to the 15th, and then y to the 20th, and then b squared. And that is all under the 5th root. Excuse me. So simplification, do some simplification here. So in order to work on this one, it would be nice to get all of the variables in, I guess, in like areas. It can be done either way, I think. But I think what they're trying to do is to get these same on both sides. Now, the book has this going a different way that I think we need to go. So let's look at the first term here. So let's just get it by itself. This is a to the 10th, and this is b squared, right? To the 12th, sorry. Well, according to the rules at the beginning of this chapter, we can rewrite this as, excuse me, a to the 10th, b to the 12th, to the power of 1/5. Excuse me again. And then you can rewrite that as a to the 10/5. That's the power of 10/5. And then b to the 12/5. Just take the number on the inside, put it on top, take this number and keep it on the bottom. And if we simplify that even further, goodness, a 10/5. Well, 5 will go to 10 two times, so that's just a squared. This is b to the 12/5 still, because you can't really make that into a nice number. So for the second term, let's do the same thing. So it starts out as square root of 5, 32 x 15, y 20, y we don't know, and b squared. So let's rewrite it as excuse me. We know 32. Well, if you think of 32 and we wanted to break it down somehow in fives, you'd say that 32 is actually 2 times 2 times 2 times 2 times 2. That's 5 twos, which is actually just equal to 2 to the 5th power. So we could write this as 2 to the 5th power right here. This would be x 15, y 20 squared, that's a 29.6, and that is all fifth. And we could rewrite that as just, okay, so this is 2 to the 5th. You can write it as 2 5 over 5, which is 1. So you could just leave it as 2. Okay, so then it's x 15. You know what? Let's do the 5 over 5. Just that's 5 over 5. This is 15 over 5. This is y is 20 over 5. This is b 2 over 5. We can simplify that, just say 2. 5 over 15, 3 times for the x. Y, 5 over 20, 4 times for the y. And b is just going to be 2/5 because you really can't put that down anymore. So this answer right here plus 2x cubed y 4 b to the 2/5 is an answer to this problem. So why did your book go different? They did it a little differently. Their ending answers here, their answers here and here are a little, oh, sorry, here and here are a little different than yours. And their B, they're a little different. I mean, we could factor out, no, we couldn't. Good. So they're the same, they're just different. But this is the way that is simpler and you get the same results, but you could always rewrite these as fifth roots, I guess. You rewrite these as fifth roots, but this answer is the same. And it worked. All right. We clear the screen. Now we're going to talk about multiplying radicals. Okay, so multiplication should find pretty good, pretty nice and easy. So for example, if we had the fourth root of 5 times the third root, excuse me, of 2, you could just write that as 5 to the 1/4 power. Now, this is a rule that you have in your book, first page, times 2 to the 1/3 power. Okay. And what we could do for this is find the least common denominator of both the 4 and the 3. So essentially, what we're doing is trying to make stuff match so we can simplify this even further. Well, I know the least common denominator is 12 because 3 times 4 is 12, and that's the least you can have 5. So let's rewrite this. Um, well, let me just show you, I guess, my thinking. 1/4 and 1/3. We know we had to multiply this one by 3, this one by 4. Do the same thing to the top that you did to the bottom. 4 times 3 is 12. 3 times 4 is 12. And you get your LCD. 1 times 3 is 3, and 1 times 4 is 4. So that's where our numbers are coming from. So we can change this to look like 5, 4. Oh, no, it was not right. 5, 3/12 times 2, and this is 4/12. Okay, so now we can take these powers and split it back apart. I mean, this is a close answer, and we can deal with this if we wanted to. We could actually move these together, but um, we can split these apart using the rules in the front of your book. This would be cube. No, well, that's why I did 12. This would be 12 of 3, 5 to the third power. Wow, that was difficult. And then, see, the 12 went there, the 3 went there, the 5 went there. So same thing here. Cube root, main number is 2. Our power is 4. And it is a 12th root right there. So now that we have both of them as a 12th root, we can rewrite it again as the 12th root of 5 to the third. And this is a property that you can find in the front of your book to combine these, times 2 to the fourth. And if you do the math, 5 to the third times 2 to the fourth, you will end up with 12 root of 2,000. And that's the answer. All right, let's clean the screen. Let's do another one. Um, the cube root of 4 times the square root of 6 equals. So let's change these to be, but we're going to simplify these in the same way. We're going to get rid of these squares. So you can rewrite it as 4 1/3 times 6 1/2 power. But this is actually essentially, if it's not written down, it's a square with a 2 there. It's understood to be 2 if it's not, if it doesn't have a power there. Excuse me. So going along the same lines, we need to find the LCD. So the LCD for this would be 6, and I'm doing it because doing it this way, old elementary school, 2 times 3, 3 times 2, do the same thing on the top and the bottom. And that will get me 2, 6, and 3, 6. And 3. Okay, so hold on. Okay, so we can rewrite these as 4 1/3 turned into 2/6 times 6 and 1/2 turned into 3/6. So we have the same LCDs. And we can change this to be now the 6th root of 4 squared times the 6th root again. Good grief, of 6 cubed. Now that these are the same, we can say, okay, 6th root of 4 squared times 6 cubed. And you can do the math to figure that part out, but this is close. This shows me you understand it. We could do some factoring and get some stuff simplified some more. But I mean, this is good enough for now. All right, I'm going to move on to another method of doing multiplication, and this has to do with the FOIL method. So if we do a square root of 2 times 1 minus the square root of 2, we can do what's known as a FOIL method or distribution. This is just distribution. This times this times this times this. And we can come up with square root of 2 because times 1, that's anything. And square root of 2 times square root of 2. Well, 2 times 2 is 4, so it's 4. And since square root of 4 is really just 2, we can say square root of 2 minus 2. And that'll be the answer. So let me just clear this. Another one would be something where we actually have to use the FOIL method, not just distribution. We have 5 minus the square root of 2 times 3 plus the square root of, you guessed it, 2 again. So let's do FOIL method. 5 times 3, 15. Got my equal sign. And 5 times square root of 2 is plus 5 to the square root of 2. Now this negative square root of 2 times 3 minus 3 square root of 2, and then square root of 2 times square root of 2, Since this is a negative, it's going to be negative square root of 4. Now we just simplify. So since we know we can combine these two, we have 15 plus 5 minus 3. 2 square root of 2 minus, well, we know that from previous that the square root of 4 is 2. So this would actually be 15 minus 2, which is 13 plus 2 square root of 2. And that's the answer. So we got one more we can try out, look at, figure out, have fun with. Square root of 3 times x plus square root of 3 also. So very similar to the one we just did, except we have x's in here. So let's do the FOR method. So x times x is x squared, and x times plus 3 is positive. Oh my goodness. Square root of 3 is just x square root of 3. Negative square root of 3 times x is minus x square root of 3. And then square root of 3 times square root of 3 will be negative because of this sign. And this will be square root of I. And we just simplify. Looks like we can simplify by saying x squared plus x would be 2 x's to the square root of 3. Actually, oh, yeah, see, if you don't follow your own negative signs, then you don't know what you're doing. So x square root of 3 minus x square root of 3 is actually just nothing. So we continue. Square root of 9 is actually just 3, so minus 3. That's your answer. All right. So we move on to division of radicals. This is our last set of examples. The division of radicals is, I mean, it's not much different. You're using the powers and you're converting between powers and squares and cubes, and you get the hang of it. So let's start out with cube of 2, root of 2, over the cube root of 9. So we should divide. So what we can do, okay, what we're trying to do is make the numerator and the denominator not 2. We're trying to make them a perfect cube. So what's perfect cubes? Like in this instance, I mean, 2 times 3 is 6. So 9 times 3 is 27. So if we put those in our calculators, I'll put those in my calculator. So let's say, I put the number, second, that button, 3, enter. Okay. But is 27. Second, that, 3, enter. So 27 is, but 6 is not. Okay. But we have to do the same thing to the top that we did the bottom. So we'll have to do it that way. All right. So what we're finding is we need to change this bottom part right here, right there, to be a perfect cube. Now, how did I figure that out? Um, I basically, I mean, okay, so 2 times 2 is 4, 9 times 2. You basically can go through the numbers. So 2 times 2 is 4, 9 times 2 is just 18, which is not a perfect cube. You can do it on your calculator. 3 times 2 is 6. 3 times 9 is 27. 27 is a perfect cube. That's basically what you have to go through. Just try each number until you get it. Um, you can think of it this way. You could just write your numbers down. I mean, 2 times 2. Did that work? No. And then try the 3. And will the 3 work? Um, will the 3 work? Yes, it will. So let's write it down. This is essentially 1 that you're making, cube root of 3 over cube root of 3 is 1. But that makes it to where it is um, um, cube root of 6, 2 times 3 is 6, and the cube root of 27. So now we can break the bottom one. I mean, we still have to keep the top one, but we can break the bottom one. 6 over, what am I doing? Oh, 3. Just 3. And that's your answer. I mean, you can rewrite it differently. You can write it as 1/3, uh, 3 to 6, but I mean, this one's equal. It really don't help you when you write it this way. All right, let's do some more. So we have the cube root of 1/5. Um, and they just want you to simplify that. So we need something that will basically, okay, let me just, you can rewrite this with one of the rules in front of your book to this. Okay. And we just basically want to do the same thing here. We want to break the bottom one so it's easier to process. Oh. So, and this is square root. So 5 times 2. Well, we know the top one is going to be 2. So let's just do the bottom. 5 times 2 is 10. But the square root of 10 is not an even number. So 3. What's 3 times 5? That's 15. That square root of 15 is not even. 4 times 5 is 20. That doesn't work. 5 times 5. That actually does work. So we will multiply this by square root of 5 over square root of 5. This will equal square root of 5 over square root of 25, which is equal to square root of 5 over 3. And there's your answer. Okay. Next problem deals with some variables. So we have x, 4x plus the square root of 6. And they want you to simplify that. Now you're probably thinking, how do you simplify this? So the book is telling you to do something. I mean, okay, there's different ways to do this. The way the book is telling you um, is to just multiply these by the opposite sign. Multiply both sides, both top and bottom, by the opposite sign. So if we did do that, like this would be 4x minus square root of 6 over 4x minus square root of 6. And then we just combine them. Now, we're multiplying here, not equaling, sorry. Now, this makes it more difficult. If we think of this as a FOIL method, it's not too bad. If we think of this as a distribution, it's not too bad either. So this would just be 4x minus x square root of 6. And this would be 4 times 4, 16, and 4 times negative square root of 6. And then this would be square root of 6 times 4, which would be positive 4 square root of 6. And then square root of 6 times negative square root of 6 is negative square root of 6. Because 6 times 6 is 36. And this line goes all the way across. All right. Now do we just simplify these down? So to simplify the bottom one, we would just, well, we did rewrite it, right? So negative 4 plus 4 is really just nothing. And then minus square root of 36, which is actually just 6. Okay. So 16 minus 6 is 10. So now we can rewrite this as, let me write this down a little further so I'm not going to duplicate it. 10 over, and there's not much simplification we can do for the top. But we can rewrite it as this. And that's our answer. So FOIL methods, moving squares and roots and powers around. Let's see what this chapter is about. So for your homework, I want you to do yeah, okay. So 1 through 54, the blue ones. So 1 through 54, blue. Not bluey, but blue. All right. Good luck.